All right, let's just review some different ways that we learned how to make carboxylic acids. The first was through alkyne or even alkene cleavage. So remember, when we have an alkyne, we can do ozonolysis. And in this case, it doesn't matter what you do, you're going to end up with a carboxylic acid. There's no way to end up with the aldehyde. So in this case, we'll end up with two of these because our alkyne is 4 carbons long. When we have an alkene, we need 2 things to occur to have a carboxylic acid. The first is that we need a proton on the alkene, right? We have to have at least 1 proton. If you don't have a proton there, you're only going to end up with ketones. And then when we do ozonolysis, remember when we learned with the aldehydes, we did a reducing, we added a reductant. Here, we're going to add an oxidant instead. Right? In this case, hydrogen peroxide, but it's just an oxidant. And so that's going to oxidize that intermediate step and end up with carboxylic acids instead of aldehydes. So for example, in this case, we would end up with a ketone and a carboxylic acid. The ketone is coming from this side because there are no hydrogens there. And then the carboxylic acid is coming from this side right here because there was a hydrogen there, but it got oxidized to an OH. From our aromatics chapter, we learned that we could oxidize the benzylic position and change it from, an ortho-para director to a meta director. So for example, if you have toluene, which is just methylbenzene, if you add some potassium permanganate, which is a strong oxidant, think about the manganese, it's +7 oxidation state. So it wants to be reduced. It wants to oxidize other things. It'll just cleave it into a carboxylic acid. And you can do this with all kinds of alkyl groups as long as there's a hydrogen in the benzylic position. And you only need 1 for it to go all the way to a carboxylic acid. Right, so we have a hydrogen in the benzylic position there, so we can oxidize. But if you had something like a tert-butyl, then there is no hydrogen in that benzylic position, so you'll get no reaction. And then finally, during the alcohol chapter, we learned that we could oxidize primary alcohols. And we could do the same thing with aldehydes because the formation of the aldehyde is an intermediate step anyways. So for example, when we have this OH primary alcohol here, if we do the Jones oxidation, remember the other ones will stop at the aldehyde. So we have to do the Jones oxidation, which can be chromium oxide, H+, and acetone. Or you might see it as the dichromate as well. That's also an option. It's the same reaction, just a little bit different setup. We go all the way to the carboxylic acid. And again, this aldehyde is intermediate step in this reaction, so it makes sense that if you have the aldehyde, you'll end up with the same oxidized carboxylic acid.